So this video is going through the ICE method, which is how to find out the equilibrium moles from some initial moles data. So the ICE method stands for initial moles, change in moles, and equilibrium moles. So let's look at an example. So 4 moles of X and 9 moles of Y were added to a container and left to reach equilibrium. At equilibrium, it was found there were 6 moles of Z. Find the moles of X and Y at equilibrium. So the first thing to do is to get our answer set up correctly. The way we set this out is going to be important. So have your equation with lots of space underneath it. We're going to put our work in underneath. And then down the side, you could just write the words I, or letters ICE, initial moles, change in moles, equilibrium moles. We're going to fill in all the data we're given in the question. So we're told the initial moles of X is 4 and the initial moles of Y is 9. We're not told the initial moles of Z, but as Z is a product, we're going to assume that's 0 unless told otherwise. We don't usually start with product. And then it says at equilibrium, it was found there was 6 moles of Z. So we've gone from 0 to 6. What we can do is look at the change in moles to get from the initial to the equilibrium, which is plus 6, and we can use that as well as the molar ratios in the equation, the big numbers, to find the change in moles for our other 2 chemicals. So as Y to Z is a 2 to 3 molar ratio, if Z has changed by 6, then Y must have changed by 4 because of that 2 to 3 ratio. Now, if our products, Z, have increased, that means our reactants must have decreased. So this must be minus 4. And again, as X to Z is a 1 to 3 ratio, if Z has changed by 6, X must change by 2. And again, as our products have increased, our reactants must have decreased, or vice versa. So feeding that into a calculator, 9 minus 4 is 5, 4 minus 2 is 2. These are our equilibrium moles.